project is powered by Calliope Mini.
Now lesson number 2 is automatic lighting. I want the lights in my house to turn on automatically when it gets dark and turn off automatically when it gets bright. And again, my lights are controlled by the NeoPixel module, so I initialize it on start, set strip NeoPixel at pin C15. In my case, in your case it might be connected somewhere else, and my module has 4 LEDs. And simply let's turn it on right now to test it. Let's set it to color red, and let's send it to the NeoPixel by using the block strip show. Okay, I downloaded it. My lights shine red. I can of course set it to any different color. Let's set it to blue and test it again. And it's blue. So this way I control my LED module. So initially I want to turn it off, set it to black, and now I want to turn on the lights automatically by using the light sensor. I will detect if it gets dark, if it's an evening, or if it's morning, if it gets bright, and I will use the light sensitivity of the Calliope Mini board. I have in inputs a block of light level. And to detect the light level, we actually use the LED matrix here at the Calliope Mini board, because it has this specific capability that it can use LEDs as light sensors. And as you can see, this block is a rounded rectangle, so it's a reporting block. It reports a value, and to use it we have to put it somewhere. So at first let's simply preview what's going on, how is the light measurement, and the easiest way to do it is by displaying it at the console. So from advanced category, serial port, I take the block serial write value X and here I put the light level block. So I will send the light level value to the computer and preview it here in the console. Let's download it. If everything works correctly, you should see the show data device here. And now I have this chart which shows the value measured by the light sensor. You see, when I cover it with my hand, the value goes down, and when my hand is gone, the value rises up. And what is also visible here is that there is quite a lot of noise in the signal. This is quite important, that in real life scenarios, the measurements are never ideal. They always come with some kind of distractions, and we have to find our way to work around it. But the pattern is clear. We can detect if it's when I turn off my lamp, you see that the value in the sensor drops. When I turn it up again, the value rises. And you can see that when the lamp is turned on, the values measured by the sensor are around 70, 80, 60. And when I turn it off, it drops down to 0, in fact. But the most important part of this lesson, in fact, is to understand how to translate our common sense when it is dark, when it is bright, to the readings of this sensor. And for each model, each controller, each sensor, it will be different, because everyone will have slightly different conditions, and their board, the microcontroller, will behave slightly different. So everybody has to test it themselves in the console over here. And the important part is to come up with a border value where we distinguish between light and dark. And if light is 80 and dark is 0, then the border between these two states is usually the safest bet is to set it somewhere in the middle, like for example at 40. So now when I know how my sensor works, I can start creating the algorithm for my automatic lamp, and it will be a simple condition. If it is bright, then the lights has to be turned off, so it has to be set to 0 and sent to the NeoPixel module. And if it gets dark, then we want to turn on the light, so we set the value of the color value to white. So this is the operation of my lamp, and now the condition, how it will operate. And again, I know that this condition will depend on the light value, but the light value is a number, and a condition has to be a Boolean value, true or false. So I have to convert this number into a true or false, and I will convert it with a comparison. If the light value is above or below a specific threshold point. And in my scenario, if at first we wanted to turn off the light, so the first part of my condition is when it is bright, when it is day, when the light has to be turned off. So the light has to be turned off when the value of the light sensor is above the threshold value 40, as we measured before. Then turn off the light, and when it is below 40, then turn on the lights. Let's test it. And now, as you can see, when I cover the light sensor, the light turns on. If I turn off my lamp, the light in my house automatically turns on. And this is the most basic algorithm for automatic lighting, but it has some limitations. Let's go to the console again. Because we are switching the value between on and off at a specific threshold, which is around 40. You see that in the moment when I'm getting close to this threshold and there is noise in the signal, the value starts to jitter. The light starts to blink unexpectedly, and it's not a not a nice user experience. If it have this kind of light in your home and it would flicker like this, I think you could go crazy with it. So we have to find a way to smooth it out a little bit. And to do this, we will not simply switch between the turning on and off the light, but we will dynamically adjust the brightness. In the NeoPixel category, here at More, we have set brightness. And now, instead of setting the light to black and white, we will always have it set to white. But now, depending on the lighting conditions, we will smoothly rise or lower the brightness of the light. And to do this, I also need to create a variable called brightness, or however you like. And now, in my condition, when the light level is above 40, which means it is bright, we want to turn off the light, we want to dim it, we want to lower it down, so we want to change the brightness by -1, for example. And when it gets dark, we want to rise up this value, so we will change the brightness by +1. And now we have to set the brightness to the value of the variable we created, brightness, which will vary depending on the lighting conditions. Let's download it. And now you see when the lamp is on, the light gets dark, and when I turn it off, the light gets brighter. But as you can see, it's somehow strangely looped. It gets brighter, 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 and then dark again. And this is because this value of brightness should be contained between 0 and 255. And when we constantly iterate it by -1 or plus, we go below these limits. If we simply display this value in the console, right now again, you said that when it's dark, the value rises, and then it rises above 255 to more. And when I turn on the light, it falls down, down. But it will also fall below 0. Like right now, it's -50, -60, and then it's gets overlapped in the change brightness block. So we have to contain these changes between 0 and 55. Only change it when it is between these limits. So I will simply add another condition. If the value of brightness is higher than 0, then lower it down. And if it is lower than 255, then you can raise it up by 1. And now simply when the value reaches these limits of 255, it stops changing it by 1. It stops adding up. And the same way, when it gets to the limit of 0, it stops decreasing it. So let's test it. Right now my lamp is turned on, so the light turned off. When I turned my up lamp off, you see that the light smoothly increased. And when I turn the lamp off again, the light changed. And if we look in the console, you see that again. Now the lamp is constantly on and the value stays at 0. When I turn it off, the value rises. But when it reaches 255, it stops rising more. To make some minor adjustment, we could also speed it up a bit. Not to rise by 1, but by 5. Let's check it again. My lamp is turned off, so the light is on. I turn it on and the light gets turned off, okay? So it works nicely.